Hey, welcome back to Fat Mama Physics. This is the last video in the Feynman diagram question series, example 7, and I believe also taken from an IB question as well. So let's begin. This question is about particle interactions. Well, an electron and positron interact to produce a muon and anti-muon through a weak interaction. The weak interaction involves one of the virtual particles, W plus W minus, and a Z0 boson. We describe what is meant by a virtual particle. So it's going to be very similar to the top over there. So let's just type this one in. It's only worth 1 mark. So it's a gauge boson that mediates one of the fundamental forces. So that would have been the force due to gravity, gravitational force, the electromagnetic force, the weak force, as well as the strong nuclear force. Okay, so let's begin. So that was just hopefully 1 mark. AI, draw a Feynman diagram that represents this interaction. So remember, every time we want to draw a Feynman diagram, we should always start with the reaction and hopefully even the constituents that are involved, the particular particles that are involved. So we have an electron, which is E minus. It's going to annihilate with a positron. So at E plus, this is going to give us a muon, and muon is going to have also a negative charge, as well as an anti-muon. So it's this guy over here. Anti-muon is going to have a positive charge just like a positron. It's going to involve one of the virtual particles, and we will draw the diagram. So let's start off with the electron, the positron. They're going to come together, meet at a junction here, annihilate. We know that the antiparticle is going to have an arrow pointing backwards in time, vice versa for the regular particle, not the antiparticle. So we will, it's mediated by one of these virtual particles, so it's going to have our squiggly line producing a muon and an anti-muon, with the anti-muon showing it's going backwards in time, and the opposite for the regular muon. So it looks like, if we take a look at this junction, so taking a look at our products here, or it doesn't really matter. We can start with our we can start off with the reactants. The minus and a positive combined together is going to give us a net charge of 0. So it looks like this is going to be the Z0 boson. And to check our products, so hopefully these two will add up. The muon and the anti-muon will have opposite charges, meaning that they will have a net charge of 0. So the likelihood of this exchange particle is going to be Z0, the Z boson, which is neutral. So the last question here is whether this interaction involve a negative boson, which one does it involve and why? So if you just said the Z0 boson, that's not going to award you any points, because notice the question says explain. That's the key word. So you have to say why it is the 0 boson, and you can say something along the lines of there is a neutral charge, or the two particles annihilate with a positive and a negative charge combined together is going to give you a neutral charge, so that the mediating particle must be neutral as well. So here I wrote down the two pairs have opposite charges. When they annihilate, it will yield a net charge of 0, and to conserve the charge, we need a boson that is neutral, meaning the Z0 boson. Okay, so that was it. This question wasn't too bad, hopefully. So yes, definitely practice more with Feynman diagrams. If I find that you're not asked to draw very, very highly complicated Feynman diagrams, if you have to draw that from scratch, if it's a complex interaction involved, then the Feynman diagram might be provided to you already, but always good to get more practice. So this is one of those things that the more practice you get, the better you're going to get at it. Okay, so hopefully you will try some additional questions. I wish you the best of luck with that. I thank you for watching this video, and Fat Mama Physics signing out.